So let's talk about the intensity of the peaks right now. The signal intensity is mainly related to the amount of IR energy absorbed. And strong absorption means that there is a strong signal, whereas a weak absorption means that there is a weak signal or a short signal. Usually the main factor which affects the intensity of the absorption is the bond polarity. As you can see here in this IR, in this part of an IR spectrum, we are comparing the signal intensity of a carbonyl group versus a carbon-carbon double bond. And as you can see here, this is a strong signal and this is a weak signal, which means that the carbonyl is absorbing most of the IR radiation, whose frequency is around, let's say, 1720, whereas the carbon-carbon double bond is only absorbing a small amount of the IR radiation, which has a frequency of around 1650 centimeter minus 1. However, the intensity of the peak will be only useful in certain cases, but in most of the times the wave number will be the most important factor that we have to look at. The shape of the peak is also gives us also some information about the different functional groups that may exist in a compound. And the first thing we are going to look at is the effect of hydrogen bonding on the alcohol or the OH group peak, and mainly in alcohols. This is the IR spectrum of an alcohol. The characteristic or the main peak which can be used to characterize alcohols is this band, broad band, which is between around 3200s and up to 36 or 3700s. So whenever you see this peak, this indicates that there is an OH group. But why is the peak of an OH group a broad peak and not a sharp peak like all the other ones which are here? Usually in alcohols we have hydrogen bonding. Hydrogen bonding causes or weakens the oxygen-hydrogen bond. And this causes a change in the absorption frequency. So if you have a single alcohol, then this is going to absorb, let's say, at 3300. Now, since alcohol will make a hydrogen bond with another alcohol, this bond will get weaker, and that's why, let's say, it will start absorbing at 3200s. More hydrogen bonding of the molecule will cause even another shift, let's say, to 3100. Now, some of the molecules will have so many hydrogen bonds, and that's why they will be in this region. Other molecules will have only few hydrogen bonds, and that's why it will be in another region, let's say 300, 3400s or 3500 and so on. So that's why we have a broad peak, because some of the molecules which have so many hydrogen bonds will be in this lower region. Some of the molecules which have less hydrogen bonds will be in this region, and other molecules will be in between. And that's why you can see this broad band here. Now, if the OH group is not, let's say if the solution was so diluted and there is no hydrogen bonding, you can see that there is a sharp peak here, which is around 3700, and this corresponds to a free OH group, which is not hydrogen bonded to any other group. So this is one of the characteristic peaks which tells us that there is an OH group. Now let's look at another one, which is the hydrogen bonding in acids. In acids, we have more hydrogen bonding because the carboxylic acid can make hydrogen bonds either at this point here, or at this point here, or even at this point here. So we have so many hydrogen bonds, and that's why in carboxylic acids, as you can see here, there is this broad peak which starts at around 2200s, and then it extends up to 36 or 3700s. There is also another peak which tells us that this is a carboxylic acid, which is the C double bond O peak, which normally occurs or appears at around 1700. So whenever you see those two, this is basically telling you that the compound being studied, it's actually a carboxylic acid. Now let's look at the effect of hydrogen bonding in amines. And in amines, the two hydrogens can stretch either in a symmetrical or anti-symmetrical way. So if we have, there are two types of amines. We have the primary amine, which has two hydrogens. And then we have the secondary amine, which has only one hydrogen. And there is a difference between those two. If you have a primary amine, then the hydrogens can be either stretching in a symmetrical way. So both, let's say, stretching and increasing the NH bond, or they could be stretching in opposite way. So this one is increasing the NH bond, but this one is stretching in the opposite way. So basically it's compressed, not stretched. And that's why there are two types of peaks usually. Whenever you have a primary amine, you will see those two peaks next to each other. And this is around, we will talk about the numbers in the next video, but let's say this is around 3200s. This tells you that this is a primary amine. Whereas since a secondary amine has only one hydrogen, you will see only this peak, which is around 3300. But look at the difference just between the amine peaks and the OH group peaks. So the OH group peaks are usually broad, whereas the NH2 peaks are usually narrow, and they have a higher intensity. In the next video, we will start solving problems. So I will show you how to read an IR spectrum, what are the most important peaks that you have to look at, what are the different regions and the main regions that we have to look at in an IR spectrum.